Hello. Today we're going to look at measures of relative standing and density curves. Uh, if we look at this situation, a data set has a mean of 42 and a standard deviation of 5. What is the value that is one standard deviation above the mean? So if I have 42, one standard deviation up, it's going to be 5 more than that, so I get 47. Now if I have 42, if I want to find two standard deviations below the mean, I go back 1, 2, and that gets us down to 5 plus 5 is 10, so that gets me down to 32. Now if I have 42 and 50, our question is how many standard deviations would 50 be above the mean? Well, I know 1 would get me to 47. Now, how much more is left? We know that this is going to be 1, and there's 3 to go out of a whole standard deviation of 5. So that we could convert this to a decimal of 1.6. What we're doing here is what we call standardizing values. Standardizing values are converting values to standard deviation units. This is something that we're going to be using throughout the rest of the year, so uh, it's something to know well. Now, to make a value into a standard deviation value or a z-score, what we do is we take the x value, in our last example was 50, we subtract out our mean, which was 42, and we divide it by our standard deviation. Now if I take 8 over 5, I get 1.6, and arrive at the same answer that I got conceptually. Now let's try it here. I have a mean and a standard deviation. So what we do is take, for our z-score, what we take is our point, 86, subtract out our mean, divide by our standard deviation. And that's going to be 6 over 6.07. It's going to be really close to 1, 0.98. So pretty much 1. Now, you should be asking, why would anybody want to know a z-score? The main reason why we use z-scores is we can compare things, whether they're the same thing, like a math quiz and a math quiz, or if they're different things. You can compare how well someone did on a history test versus how well they did on a science test, even though these things might be um, not equal difficulty. Or somebody running a 400-yard dash or a 100-yard dash. You can't just multiply this by 4 and say that this person's faster, because you can go a lot faster when you're just running 100 yards. So we can compare things that that we couldn't compare before. For instance, on a history test with a mean of 40 and a standard deviation of 4, Ed scored a 44. Ed scored 44. On an English test with a mean of 30 and a standard deviation of 6, Alice scored a 35. Who did better relative to their peers? Well, Ed, he got a 44. If I subtract out the mean and divide by your standard deviation, he has a z-score of 1. So he scored 1 standard deviation above his peers. Let's look at Alice. Alice had a z-score of 35 minus 30 and divided that by 6, and that's going to be 5.6, which is 0.875. So that means that Ed uh, did better relative to his peers because his z-score is higher. He's 1 standard deviation above his mean, where Alice isn't quite 1 standard deviation. All right, hopefully that made sense.